Hello everybody, today I'm gonna show you the EE542 Lab 5, how to modify TCP protocol to achieve our goal in a highly congestion and lossy network. So here we are, follow the Lab 5 through. We are here to clone the code of the Linux kernel. Here I have finished the cloning. So here we can see the bionic file we are using. So for now, we need to after the cloning, we need to go into that file and actually build that file. I have installed those libraries, so I will skip that. But for you, if you are not ready, you have to finish all these installations. And here we are. We will use the second approach just to make those changes. I have made the first one, so let's just start with the second one. With that, and see, we have the here bionic. This is our clone file, and try this one. I have eight CPUs, so I will J8. Let's go. Okay, so this error shows we are not have this rule. So for now, we should go into that folder and try this again. Oh, not found. Make file. Found. Because I don't have the old configuration, so let's use this one. Make old config. So this is really uh, like this command line is very exhausting, which needs you to be here and continually pressing your keyboard. So let's use another uh, approach, which is make, make the def config, which is automatic way to build your config. Now we can start building. Try this one. Oh, it started. Let's use J8, not J4. So in here, we can see here, it is already starting building. So for now, we should pause for a while because this approach takes a very long time to build. If you are, if it's the first time to build those files, so it's not meaningful to wait here to actually wait compile. Let's pause here until it's done. Now, guys, here it is done compiling the code. Uh, let's say debug uh, the package source. Yeah, these are only the step one. You see, we should do the step two, cd dot dot, and do this one, sudo the package. Yeah, this is the step two. So usually, whenever we change our code, modify the source code, the kernel code, we should do these two previous steps, and which are usually the largest time consuming parts. Yeah, here it is running the code. So yeah, let's pause here until it's done. Okay, few minutes later, it is done the depackaging process. Now let's follow the PDF. This is we need to change the graph bootloader configuration. So let's find these files. First, open the file and go to the boot grab and this one because I don't have the first one. It is the legacy configuration file. So only I have this one. From this one we can see search for advanced options for Ubuntu and yeah we can also check our currently using the kernel code. What is that? Let's see. The username unique. Yeah, I'm currently using 5.4.0 generic. So according to the PDF, we should modify this configuration file, change the newly one. The like let me see how what we are using is see it should be this one. So let's modify it to this one. So it's already like the on the top. So everything should be fine. Let's reboot the virtual machine. Okay, this is the arrow shown on my screen. You can see here the virtual machine is not putting up because I didn't change the anything on this file. I don't know, maybe something changed. Maybe some changes will happen if I modify this file. So if you are doing this if you are doing this lab and if you are wondering how to modify this or what if whether you should modify this, you can see mine because I didn't change anything and the system failed to put up. So I have to reset to its snapshot previously and do all the things about and modify this one and reboot. See here store restore the snapshot. I don't know whether this approach works or not. Try this one. Or so if you are using AWS, you know, we our group has actually crashed the AWS instance by doing the same steps. I just didn't know whether the problem was whether it's my virtual machine or the AWS instance or the steps. So for now, yeah, I have loaded the snapshot here. Let's do the same thing again. So this snapshot shouldn't contain anything related to the GitHub clone and the. So for now, I have to do the thing, all the thing about again. Sorry. Oops. Including GitHub clone and the package, all the things. Yeah, there's no file name here. So I'll just pause here until everything is done. Well, we are compiling the code again. Let's check our code modifications. So to achieve this, we want to achieve better performance of TCP. We need to modify TCP source code in the file. So basically, I will demonstrate what my group has done. First, let's see here. Include, yeah, you can see here changes the commit code commit name made by my group made by my group member, and per changes will like from difference to big. Let's go into the file and see what we done. So we basically modified the TCP include file. Here, why don't we just see the changes? Oh, sorry, I didn't know that. Let's try again. Let's try again. Too long to generate. Maybe too large. Um, okay, let's try this one. Let's copy this file into the virtual machine we have. Well, we are not done yet, but we can see the changes, right? Okay, okay, I see her comment. So this is Lab5. What I've done is we increased the window size because the more window size we have, the more packet we will send within a time circle, right? And what about other changes? Also we decrease the TCP fast retrans threshold so we can make more fast retransmission. So basically, originally TCP had three fast retrans threshold because this is a protocol design. Now we have reduced it to one. So we will make more fast retransmissions because this is a highly lossy network. Second one, this is how many retries are done when active in a connection. This is also a modification to ensure we have more transmissions. And decrease this one. Zoom in a little bit. Timeout. Decrease the timeout time so we make more more retransmissions because the timeout time has been decreased. It's also meaningful changes. Enable the socket fork and increase the window size. How meaningful changes? What else? Like that's all for the header file. So we basically increase the window size and the retransmission time. We actually generally we highly enhance the possibility to retransmit the packets here. Next, let's see the actual changes in the .c files. See IPv4 and there are many changes also. TCP.c. I don't know if she commented out, but let's do the simple way. Just copy the file and paste it here. Paste it here so we can change this. Okay, let's go through from top to bottom. So these are changes. So some changes are made by ours, some changes are made by other teams. Because I'm using a different version right now. Okay, let's see, there are some meaningful changes, or we should search Lab5. Nope, she may not. Okay, these are some functions. Here, the read ones, we have changed those files. If unlikely, versus backlog. Oh, this is the actual implementation of the paper. Yes. So we are actually recording all these parameters and the variables. So the next time we transmit, we'll make more full meaningful usage to the network. So yeah, basically this is all our implementations. See this one. There is a commit history that's here. Change. It's directly change. Oh, similar. Or I don't know how to see that one file changes one time. Oh, yeah, basically, we have modified this file and see here some parameter settings and the functions. And let's see what else. Maybe later, can like add a file detailed explanation to the to the GitHub or to the section. Level 5. Where the okay, yeah, basically so now those files and these are some detailed changes which is not usually suitable to illustrate here. So let's wait to stop. Just came up with I just recall we have deployed our code into the AWS instance later. So actually, we are now able to test our code online on the AWS instead of using my own virtual machine, which is really slow because I don't know why my actually the bandwidth of my local area network is so slow to actually test the file transformation and transfer, and actually the bandwidth is less than the limit, which is 100 megabits, so megabits. So here I have opened our AWS instance. So let's actually start testing the code, and I have set the network to 100 milliseconds and 5 milliseconds. No, 100 milliseconds and 5% loss. So let's try its throughput. Once here it is calling the SCP functions. This is data bin we are sending, and this is the time, and it is the bandwidth throughput. So it is 1.5 or 1.3 megabytes per second, which is relatively acceptable because here, let's see our the TCP performance here. You can see when it's in this scenario, the bandwidth of TCP is actually lower than 41 kilobytes, which is really slow. And you know, if you want to transfer a 1 GB file, it is often unacceptable. So yeah, for now we can see, yeah, it's running, though it's not very fast, but it has achieved a better performance. And let's try another scenario. So I pause here, and I will adjust my router configurations. To pause. No. I'll pause here. We forgot the hotkey. Okay, I found it. Now I have changed my configuration to 200 milliseconds with 20% loss. So let's try this one, see if anything changes. Let's see the throughput. Oh, you can see the dramatic decrease on throughput and the ETA because you know the network is getting worse and worse, but we are trying to fix that issue by resending more and more packets. You know, by increasing our window size and decrease the retransmission time. Also, we keep increasing the window size, and we will send more packets at a time. So actually, although the network is very lossy, but we will send more package to to contemplate this default this scenario. So we can see here we have already have an acceptable throughput here compared with TCP. Actually, really zero is actually when we are testing, it is impossible to transfer the file. So that's it. This is our Lab5's project, and I will wait here to wait it to be finished, and I will finish my presentation here. Thank you for watching.